can't really fast move.
Okay. All right. Now, are we back live, Mark?
Mm-hmm. Yeah, you're good to go.
Okay. All right. So we're going to continue with our hands-on. And in the interest of being able to finish everything and complete our exercises today, what we're going to look to do, so we'll still continue to circulate and help everybody individually on site. We're going to continue to monitor the chat for questions coming in. We'll address those as they come up. But what we're really going to probably have to do to make sure that we can tie together all the different sections that we learned today, what we're going to try and do is reserve some of the larger questions to the end of each segment of training, and then we'll address everybody all at the same time with those larger questions. And this way we're going to be able to reserve time for the areas of the program where there's going to naturally be more questions when it comes to live load, when it comes to stage construction analysis. And that will then help us stay on track that tomorrow we're going to be able to divulge all of our time for designing and modeling more complex steel girder bridges and really dive into the details for code check load rating. So Delara, if you want to start us up with the page we're on in the manual, and then the model that we're going to begin with.
Okay, so we are at page 23 now. We will start to model the geometry. We set our bridge pad coordinate system. So now we will create some joints together. So you can continue the model you have saved previously, or you can use model named 2 defining the bridgepad.lar LAR file. So you can use this one to follow me, or you can use your own model that you just created. Okay, now we will create some joints. To open the joint spreadsheets, I will repeat. You can go input data, geometry, and it directly opens joint spreadsheet. Here you can enter joint coordinates. That's what I will do now. So for the first joint, I will double click to the row and create a row, and its coordinates is 0, 0, 0 for station, transverse, offset, and elevation. And we will create the second joint by double clicking to the row, and the station for this joint is going to be 100 feet. So let's look at in graphics view. From the top plane, you can change the plane by using
or if you could just click the tab.
Okay. Okay, so let's look at from the top view. To change the view, you can use these tools. This will show you the top plane view. So let's see, this is our first joint. It's in the origin of the bridge pad coordinate system. The coordinates are 0, 0, 0. And when I entered station 100 feet for the second joint, it's created on the alignment that we defined, bridge pad coordinate system. So its transverse offset is 0, and it's on station 100. So do you have any question?
Yes, station 100 was about PO1.
Can you repeat?
I mean, the station 100 is supposed at the PO1. How do you know? Yeah, that's the one.
We will create its restraints in a minute.
Okay.
Okay. Okay, then let's move to members. Okay. Now you can switch to but top plane, as I mentioned, by using this tool, and see the joints. Now we will draw a member between these two joints. You can use also this 3D view. Let's see. Or let's stay in top plane. Okay, to draw members, I will get draw tool by going input data, draw, geometry, members. In input data, you can go draw, geometry, members. And you can get the drawing tool. And it will directly open Model Data Explorer in the right-hand side. And here we will specify some properties for the member that we are going to create in a minute now. So now you will see in the Model Data Explorer. Is there any question? Input data is in the main menu.
Are you in the graphic view? Go to the graphic view.
Input data. You should activate the graphics view first. Okay. Before going to input data draw, please close the spreadsheet, join spreadsheet, and activate the graphics view. And make sure you are at the top line. Please close the spreadsheet and activate the graphics view and go to top line. Okay, and then you can go draw, geometry, members. Okay, and it will open Model Data Explorer in the right hand side of the screen. So now we will set the properties for the member. For section, we will select symmetrical I-beam. And for the material, we will select A70950, steel material. Okay. So it should be in the right hand side. Let me see.
See where it says properties on the right hand side?
Here. You can select section there.
Symmetrical beam.
Yeah, symmetrical beam in the right hand side. And material is going to be A70950. After setting the properties, you can click. Sorry, we should also set the angle, orientation angle. It should be 90 degrees. So please make sure you set section, material, and orientation angle for the member before draw anything. Now we can draw our member.
What's the end section?
Same, leave the end section as same as start, as you see in the view that I'm just sharing. Okay, same as start. Now let's click the first joint, joint 1, and joint 2. When you locate the joint with your mouse in the graphics view, it will draw a circle around it and you will know the joint. Okay? You will draw a member between joint 1 to joint 2. Okay. And now you can close this drawing tool. Okay. And now we will see this created member in the spreadsheet. You can open the spreadsheet through going input data, geometry, and this time you can search to members. And here you will see the draw member between two joints, and it's section is here, its material is here, and the defined orientation angle is here. Now,
Join 3 and 1 to 3.
we have 2 joints at this moment. We don't have joint 3 yet. Let me see. Member between joint 1 and joint 2. Okay. So after drawing the member, you can switch to complete rendering by going graphics, complete rendering. Input in the menu, you can see graphics at the top, graphics, and complete rendering. You can see in the screen. Here I'm showing. Graphics, complete rendering.
Why don't have graphics? Why not?
You can close this one.
Okay.
Make a graphic.
Oh.
Yeah. Okay.
I have to close that and then shrink.
You can just continue.
Okay.
We will do together.
Okay.
So if you if you open the complete rendering, you can switch to 3D view by using this tool and see the cross section of the girder. And now, as you can see, when we look at in the top plane and go to simple rendering, the beam is not following the curvature exactly yet because we didn't make a refinement. We didn't mesh this beam yet. Now we will break this element into smaller pieces, smaller segments, and we will see that some joints will create it automatically to follow the alignment. And our girder will fit on the curved geometry. So let's refine the model now. Now, let's use the select graphically tool to select everything, to make sure everything is selected. In toolbar, you can click this little arrow near the select graphically tool, and you will see the select all option. Click on it. And now we select everything. And then we will break this member by going modify in the main menu, modify, and then we can select the break members. Now we will enter number of segments that we want to have on this beam. Is there a question?
Yeah, I missed that part. What? Modify. Okay.
In main menu, you can go modify.
Yeah. Okay.
Break members. And number of segments should be 20. And then you can click OK. And you can see the created members, the segments, sub-segments. And our girder is fit on the curvature because interpolation is made by considering the alignment internally.
So all you have done is break the member.
Yeah, all.
So then come on.
Yeah, because since not all we did is just breaking, we activate the bridge path coordinate system. That's why we have this curved geometry. The first thing we did is activating the bridge path coordinate system and make it the current user coordinate system, and then we break little pieces and have this curved geometry. Okay, so now if you have any other questions, you can we can discuss. No? Okay, so let's continue with the generation tool. Now we will create shells and other girders in our project. So we will have girders with 12 feet spacing, and so let me see just a second. Okay, we will have 4 girders, and we want our deck mesh as seen is as at page 30. Can you look at page 30, please? Now, when your deck mesh is like in this figure, you between 2 girders, you will have 2 shell elements. So now we will extrude this section, this geometry, to have 1, 2, 3, 4, 5, 6 shell elements. So that's why we will enter 6 repetitions for our extrusion tool. So let's open the extrusion tool. Please follow me now. Go draw in the main menu. Generation. Draw generation. And make sure you selected this repeated copy segment here, repeated copy part. And make sure the coordinate system is bridge path UCS. And number of repetitions is going to be 6 to have the aimed geometry for the deck.
Is there a reason behind the 6, or that's just what you?
So is there a reason for 6, or I just came up with? This is our modeling approach. The reason is T-bridge module is also modeled. The deck is like that automatically. So that's why we chose to show you this way, because it uses this way of modeling in code check, and it defines the tributary deck width for code check. So that's why we have 2 shells between girders, and composite girder will have 1 shell element at both sides. Okay. So let me repeat this extrusion part. We don't use this repeated copy. Sorry for that. We need to use extrusion.
Why? I don't have the window, what it called the
You don't have
element time. Yeah.
Right.
extrusion.
Oh.
I'm sorry. I just said select repeated copy, but it should be extrusion in generation tool.
Yeah, exactly.
Okay. We're good, right? Yeah, okay. So in extrusion, we select bridge path UCS, and repetition is 6. And we will not create members between girders, but we will create shells between girders. That's why we will just unselect members, but only include shells. And After you set everything, you can click OK. Oh no. Yeah, I forgot delta. Yeah.
Is that delta is that the half spacing that we're setting there with the delta?
Yeah, delta will be the deck spacing. Yeah, for the
So it's half. It's a tributary area.
it's half of the tributary area.
Yeah, so it's right. You'll have a right left shelf.
Yeah.
Okay.
Yeah, your total tributary area going to be 12 feet
Yep.
for girder, and between girder, the spacing is going to be 12 again.
Yeah.
Yeah.
So you'll have one to the right converter, one to the left.
Yeah.
In the model.
Yeah. Let me repeat this part.
Half converter spacing.
I have screwed already. What was that? That's,
Yeah, that's correct.
that's correct, okay.
So that's correct. So let me repeat this process. I go draw, generation, extrusion, and repetition is going to be 6, and delta transverse offset is going to be 6 feet. And I will include shells and exclude members. So between girders, this is going to create girders also. The selected element chain that we give to the tool. So it will create, it will extrude these elements also. And between these elements, we select shells. We will create shells between those elements. So if you see multiple girders, it's correct now. You should see something like this.
7 girder.
Yeah, yeah. Mm-hmm. Yeah,
Beg your pardon, can
we
you
have a
repeat
question.
that again? Can you just repeat what you said?
Okay. So so when we go this extrusion tool, we select a member chain. So it was our girder, the girder we just created. And this extrusion tool will copy that girder also. And we tell it a repetition, and it will copy that girder 6 times because we enter 6 repetitions. And between these repetitions, we select shell elements, and shell elements will create it between the copied girders. That's it. That's what this extrusion tool did. I think you skipped I think we have a question in chat, John. Can you tell me the question?
Yes, Laura. The question that we just had in the chat here is why are we excluding members?
Huh.
So when breaking members, we do have a response back here. When breaking members, it nicely subdivides and realigns the bridge geometry. And then additionally, how do you subdivide keep it as a core? Or we can circle back to that. But additionally, why not repeated copy instead of extrusion?
Yeah, it was not a repeated copy. I made a mistake in that part. It's extrusion. It's like that in the manual also. I just missed that part. We did extrusion. Let me repeat that part. We go modify, draw, generation, extrusion. It said extrusion. And I think one of the questions is why we exclude these members.
Yes, correct.
Because if you include these members. These are the elements that you want to create between copied elements. So we want shell elements between girders, but we don't want to have vertical transverse members generated between girders. That's why we just exclude members. Okay. So this is, we are at this point now. Let me go simple rendering and look from top. Now at this point, to the simplicity of the modeling, we will convert our geometry to a straight one. Please follow me. In Model Data Explorer, we will switch the coordinate system. And we will right click to the bridge path UCS. And we will select Convert to Global System. And you should have a straight geometry now. Okay? Yeah, okay. Okay.
Where is Canada? Are next?
See the drop down where it says member?
Let's unselect all elements by using this unselect graphically tool. You can click on this little arrow near unselect graphically tool and select unselect all.
Oh, okay. Yeah.
Do we have any question? Okay, now we will create some overhangs now. The girder at the bottom will be our first girder, and girder at the top in this top plane will be our last girder. So let's select only the first girder. Let me use this one. By using this graphically selection tool, you can just draw a window from left to right. Just get the first girder, okay? You can use this hide unselected option to check if you select correct elements, and you can activate it again, deactivate it again. Now we can create our overhangs again using the generation tool. We will go draw, generation.
Can you just show this hide unselected button?
This one is hide unselected. Okay, so I will go generation tool now. Draw, generation. Extrusion. Again, this time we will use global coordinate system because we changed our alignment to global system, our coordinate system to global system. And we will have a single repetition. Okay. And delta y is going to be -3 feet. And it will be our overhang width. along the side of the first girder. And let's uncheck these members again, because we don't want to create members in that side. We just want to have shells for the overhang. And now let's click OK. And this will be our overhang. Extra members, as I mentioned, the selected member chain will be copied with the extrusion tool. We will erase those extra elements later. We have a question over there. Yeah.
But we didn't show the yellow line over there. Is that select correctly? Just show the gray line.
This one?
But here's probably there's a color effect. Didn't show the.
Let me see.
I'm not sure that's the.
Okay. So now let's create other part of the overhang. So now I will select the last girder at the top of this top part of the top plane. Let me say leftmost girder. Select only the members, and you can use hide unselected option. And again, go modify. Draw, generation, extrusion, and make sure you have global coordinate system now for the straight geometry. Our repetition is going to be 1, and delta y this time is 3 feet, not minus, but plus 3 feet. And element type is only shells. And click OK. Okay. So when you go to complete rendering, you should see model like this. Okay. Now we can before we are going to delete these extra members, but before that we will look at the local axis of the created shell elements. Okay. So let me go back to simple rendering and look at from the side plane. Okay, you can look at from the side plane by using these tools in the toolbar. And to see the local axis orientation, you can go graphics, show, display icons, and include this local axis. And in this unselect graphically tool, click on little arrow near the unselect graphically tool and unselect all members. So here you can see that. Let me show you in the 3D view. We have local axis for each shell element, but their origin is different. So now we will put the local axis of these shell elements in the same direction. To do that, while these shells are selected, to make sure all shells are selected, you can use this select graphically tool and select all shells. And then go modify shells, put local axis in same direction. So it will adjust the local axis. Okay?
Could you modify shell?
Modify shells, put local axis in same direction.
Oh,
And then you can close the local axis display by again going graphics, show, display icons, local axis. Just inactivate this one.
I'm sorry. Yeah. What?
You can go graphics, show,
Yeah.
display icons, and you can uncheck this local axis now.
Oh, okay.
Okay. Let's go to our shell spreadsheet. So let me look at my time. Input data, geometry, shells. And now we will enter material to our shells. You can select full column for material by clicking on its heading. And in the toolbar, you will see the spreadsheet editing tool here. Here you can select FC4.
Toolbar. What's toolbar?
Sorry?
I mean, what's toolbar? What?
Tool-
What's the, toolbar. Yeah, what?
Toolbar.
And what?
Yeah. In the toolbar, you will see a little cell here. Here you can select FC4 and click the check mark.
Yeah, I go to top menu.
Okay. Okay.
Toolbar.
And now we will update the thickness of the shells. Now, the same way, we will select the full column for thickness.
That's not right.
And here we will enter 9 inches. And the same way, we will select the check mark near the cell. Let's see. In the graphics view, in the complete rendering, you should see the deck thickness now. And you can use the shrink option.
Check.
Now, while you are in complete rendering, it's easy. Please stay in complete rendering and unselect all. And then take this select graphically tool. And select extra girders that we created. This time you can select just half of the section by drawing a window from right to left. Okay. And you can use this hide unselected option to see if the correct elements are selected. These are the extra members. We will delete these ones. These are not actual girders. Okay. After you select, is there any question? No? After you select the extra members, you can go modify and erase and say yes. and you can deactivate hide unselected option. And now in this view, you should have an overhang width at both sides for the deck. You should see 4 girders, and between girders you should see 2 shell elements created for the deck. Okay, good. So now we will continue with the member end offset. Now I will go input data, geometry, members. Now as you see, we need to enter some offset for the members to bring them to bottom of the deck. So we will enter an offset, and it should be, the value should be half of the deck thickness plus half of the girder depth. And its value is written in the manual at page 35. It's 2.875, and we will enter it in member end offset. So let's start from the beginning. So go input data, geometry, members, and you will see member end offsets tab. And for the I joint and the J joint, we will enter offset in vertical direction. These are in global coordinate system. So we will enter a Z offset, the vertical, in the vertical direction. So let's select the full column for I offset Z and go to spreadsheet editor and enter minus 2.875 feet and click on the check mark. Now we will do the same thing for the J joint. Same value. And when you go to graphics view, now you should see our girders are below the deck now. Okay. We will create substructures explicitly for, we will create piers explicitly. Now, for now, just to show an example, I will create some restraints in this model. So first, let's look at from the side plane again and see this view. Now, for the end of the girders, for the abutments, we will create a restraint, and we want those restraints at the bottom of the girder. So our connection joint of girder and deck is at the top of the girder, at the deck location. So now we will create rigid connection members to model the section depth and have restraints at the bottom of the girder. We will do it for the ends only. So let's set rigid member properties first. So this was a question at the beginning. We will set these materials in this properties spreadsheet. We just basically create a new row and enter properties here. So this is what I do for the rigid material. So instead of setting the material, we can switch to another model, and this way we can make sure that all of us at the same page. So please close your model and open the resource folder Model 3 geometry generation. Okay. Are we okay? Can I continue?
While we are switching the models, while we are switching the models, can we continue with our existing
It
models?
was just saving time, but if you want to continue, I can. We can continue this and make sure everyone is on the same page.
Okay.
So if you don't want to
Because
open,
some of us have the model correctly set up. Can we continue?
yes, you can continue. Let me continue also.
And Shimna, if you could just reference the page in the manual that we're on now with this next segment.
We are on page 36 now. Okay, let's not switch between models. It's up to you. You can switch that model also or continue with your model. So let me continue by setting rigid elements. Now we will enter in material spreadsheet input data, properties, material spreadsheet. I will enter rigid material property. And I will just copy the property of the steel material except the unit weight and paste for the rigid material. So I will not use a unit weight for this material in this way. When we apply self-weight, its self-weight is not going to be included. And similarly, we can create a section by creating row in the spreadsheet. So I will enter rigid connection for the section. And it will be approximately 10 times stiffer than the girder section. So please enter the properties that you see in page 37 for rigid connection section.
Can we go back to materials, please?
Materials.
Yeah.
Did you say you wanted it 10 times different?
I think 10 times larger values than this.
Material definition, just look at the screen. We complete material and continue from there.
It's 10 times larger values than the girderized section. So this is design choice for the rigid elements. The property of the rigid elements should be a designer choice. So you can set this properties in this spreadsheet.
How can we change the no to yes?
We will assign it later.
Next step,
Mm-hmm. What?
In the design manual, the screenshot says assigned yes, but it should not be assigned at that point. Just ignore if it says assigned. Okay?
Yeah.
Okay, does everybody have the material? Rigid connection material?
Okay. So if everyone has the material and section for rigid connection elements, now we can continue to define our supports. So now let's go back to graphics view. Just close the properties spreadsheet. Go to top plane. Switch to simple rendering. Unselect all by pressing U in your keyboard. This is a shortcut. It will unselect all elements. Then you can get the select graphically tool. Is there a question? No? Okay. And now let's select the joints of the girder. So it's you will see the girders better when you activate the shrink. This way, the yellow will be the girder line, and we will select the start and end joint of the girders with the tool, select graphically tool. Okay. So you can again use this hide unselected button to make sure you select correctly. You should only select joints now at this point. Go input data, geometry, and in joint spreadsheet at the bottom you will see show only selected objects. Check this option and select all select the coordinates of all joints. Right click to it, copy them, and we will paste them later, not yet. And when we paste these coordinates into this spreadsheet, it will create new joints. So to paste them, we need to deactivate this show only selected objects option. Let's deactivate it by using this scroll. Go at the end of the spreadsheet and click on the X coordinates in the empty row. Right click to it and paste. Okay. Now you should have extra joints at the same location as girder joints at ends. Now we will update the vertical coordinates of these joints, and it should be half of the deck thickness plus the girder depth. And we are trying to create joints at the bottom of the girders. So, and let's enter minus 5.375 feet and select the check mark. Click on this check mark. So if you go to graphics view, just in the window bar at the bottom, you can switch between windows. Let's activate the graphics view and see the joints created at the bottom of the girder. Okay. You can use this hide unselected option at this point to visually see just the girders. So now, between these girders, we will create rigid connection members. We will draw members. For that, I get this draw. We have a question over there. Okay. So, do you have any other question? No? Okay, let me continue. So you missed something?
Yeah, I missed some, so I think I have to read. I don't, I couldn't find my structure where.
You need to activate the view,
Okay.
graphics view.
Yeah.
And after that, just tell my friend and she
Yeah,
will
okay.
open the model
Yeah.
for you. Okay.
So now let's draw some members between these joints, and they are going to be rigid connection members. Just like we draw girders, we will draw these elements with the drawing tool. While graphics view is active, go draw geometry members. And in Model Data Explorer, switch to section to rigid connection and material as rigid material. And you can leave angle as 0. Okay. And now we can start to draw members. You can follow me. You should select the joint. To make sure you select the joint, you can just look at near the arrow, near the cursor. The joint ID should be shown if you are selecting a joint. Otherwise, you can draw members in space, but we want to create members between joints. So make sure you are selecting joints. Make sure you are seeing the joint IDs. Okay. Then you can close this Draw Members tool. And you can deactivate hide unselected option to see the full model. Now we can create second and third spans. Let's switch to front plane. This one, front plane. Now by using generation tool, we will copy this span to the for the other spans. For that, let's select all by pressing S in your keyboard. This is another shortcut. To select all, we can press S in our keyboard. Now we will copy this span, but we don't want to copy rigid element at the end. So we don't create duplicate members at that point. So that's why we can unselect by taking this unselect graphically tool. We can unselect the first rigid member group in the first line, in the front plane. So you should unselect the rigid connection members at the start of the geometry. Okay. So now you should have everything selected, but you should unselect rigid members at the front, at the beginning of the geometry. Then you can go draw, generation. This time we will use repeated copy, not extrusion. And we will create 2 repetitions in global coordinate system, and our span length is 100 feet. We will enter 100 feet. And we will create 2 more span. This way we will have 3 spans with 100 feet spacing. And you can click OK now. Okay. So this is 3D view, and in the side view, in the front plane, we will continue with the front plane. Let's unselect all by pressing U in your keyboard and select bottom joint at the beginning of the geometry. Girder bottom joint at the start of the geometry. And skip the second one, but select the third and fourth joint locations at the bottom of the girder. Now we will define some restraints for these joints. Do we have question, John, in the chat maybe?
Not that I see that is coming, no.
Okay, so okay. All right. So now we will set the restraints. For this we will use Model Data Explorer. In this Explorer you can switch back to joints, and you will see restraints here. And we will fix translation Z and Y for these joints at this point. Just to show you an example for the basic support. And for the middle joint, I will other middle joint location, I will unselect all and select second support group at the bottom of girder. So 4 joints should be selected for each girder, and we will fix this joint in 3 translation directions. Okay. Do you have any questions?
See that we're all model generation before we go to groups. Try to get everyone on the same page.
Yeah. Let's try to be on the same page before going into the structure groups. If you have any questions.
That's what needs is several steps, yeah. Let's try to follow. We generate the first plan.
Now you're trying to generate.
Yeah, try to probably catch up there. I think that's, when you get here, I'm gonna need some step around this area.
Did you delete the extra orders?
No, I don't think so.
So maybe you can go to complete rendering in graphics. Complete rendering at the end of the menu.
Oh, complete rendering, yeah.
See? Okay, you didn't delete the extra orders yet?
Yeah, I did was, and then for some reason, yeah. How do you get the big one? Try to
You can use this Zoom window and
And
you can change the side plane on.
okay.
Now you can delete the extra members and use
Yeah, several. Yeah, I try to focus on everything.
in this panel. You need to delete these ones.
Okay.
The ones to do this, you can use the view to unselect all.
Just right.
When you click view, you don't see anything changing in the complete
Right.
it's complete rendering. You will see something will change in single rendering.
Okay.
But we need complete rendering now to see the orders clearly. So we unselected all. Now take this selection. Yes. You can select this order, this one.
Okay. Why didn't it show up?
Yeah, because you're in. No, this red line will not show. I just
Okay.
changed it.
That's all right. And
Yeah.
this one?
Select them and I will. You haven't.
Yes, I got lost. So I can't see the screen.
Yeah.
I missed two steps.
I mean, it's a several steps. How do you undo that? Undo, I did too much, too many.
Always until my screen looks more like hers.
Okay.
That's what I want.
Personally, open it between the I'll introduce every step. Yeah, that's the way I learned. Oh, yeah.
If I don't understand, I don't move
Oh. My everything.
like the outside they are putting. But outside means we are.
So I asked some questions. Number
When you were originally putting
Blue on a black background.
That's right, delete that's delete mode. Like, I select whether all of it to modify.
Don't do that yet.
Oh, okay.
Check first. Click on right on select.
Oh,
But you select all your.
I selected this, but why it show there? Well, okay, unselect. Right?
No. Let's
Yeah, sure.
So we should just unselect one and like it.
I follow this. It look like.
Yeah, but you select more than that.
Okay, just this line, right? What it show you with the rectangle, that means this because need the select or.
Yeah, that should be selected.
Where did you find that?
Yeah, why you say it's blue? Not.
Let's go that one.
Yeah.
And let's see. We have one here. Okay.
Oh, it's already select, right? Because okay.
Unselect this and select this. Unselect this. And it's
Oh, because I already select. Why did it? Okay, I see.
You
Yeah.
can go now modify them gray.
Yeah, and then.
Now you have on one border. Okay. Now you need to define membrane poster. Okay. Membrane poster.
Remembering that word go.
Input basic. What one? Input basic. Members.
Yeah.
Membrane poster. There.
And also the color.
Okay. Yeah, I see the new step one. Yeah.
Specify this element and apply the changes for the multiple steps. You just click on the heading to select all and change something. You can enter here and
here.
apply all of them.
You up. Oh, this up right? What's
So you
the
will
this?
enter this value.
Connected.
Sorry, it's more
Oh, sorry. Yeah, I.
First select the
Yeah, color. Yeah, and then here.
Yeah.
Fine.
So,
X, Y, Z. All three translational directions are
And J.
okay.
What?
and then you
Okay, so let's continue with the structure groups. Now we will select some elements. Let's get this. Sorry. First, set our selection option. To do this, I will go in selection and use the select joins of selected objects. And this will include the joins of selected elements with the graphically selection tool.
Yeah.
Okay, sorry. Let's start from the beginning. We will unselect all by using U in your keyboard. Now, I will select all shells by clicking on this little arrow in Select Graphically tool. I will select all shells. You can use this hide unselected to check if you select just shells. And you can go selection, select joins of selected objects, and it will include the joins of selected elements. Now this will be our deck, and to group these elements we will use a structure group object in our project. So this will help us to select certain portion of our model. And to create group in the Explorer, I will click on group heading, and it will open structure groups. There.
Oh.
And while I select these shells, I just click add group button. So this command will create a group with the selected elements only. So you can go inside the spreadsheet of this structure group, and in joins part you can see the selected joins. In the shells part you can see the selected shells. And if you go members, you don't see any members because we didn't select any members. You can close the spreadsheet of the group and rename the group as deck. Okay. Now we will create groups for girders, but before that we will create a girder folder. We have a question here. Yes.
So you can unselect everything first by using U in your keyboard. Okay. Then to select all shells, you can use this little arrow. Yes, and all shells, and you can activate this Python selector. Now you can go group in your Explorer and click add group.
And rename it as deck. Okay. Now we will create girder groups, but before that we will create a folder for the girders, because it's good to organize these structure groups, because you may have many structure groups in your project. Yes.
Yeah, I didn't have to yet.
Okay.
So that's select the joints of the deck. Before that, you need to select the shell first. And yeah, you can use that one. The old shell. And you can go selection. Select joints of selected object. And then you can activate Python select. And you use that one. Now you can click back to Python. And you can delete the first one. And rename it as that. Okay, let me show you. I didn't show you that part. I will come to that part now.
Okay. Let's unselect all by pressing U in your keyboard. Deactivate hide unselected. Or let's do it this way. Select all by pressing S in your keyboard. And in Structure Groups Explorer, click on deck group we just generated and click hide. Okay.
Click where?
And in your keyboard, you can use U again to unselect all. Oh.
Hide.
And you can get this graphically selection tool. And you can select first girder with the graphical selection tool and click add group button and rename it as girder 1. You can go selection at this step while your girder is selected. You can go selection, include element joints. It's not seeing that. It's not working in that way. Let's follow the manual. It's not working. Do you want to follow the manual? This is another way, but it's not working now. So let me start over for the girder 1. Okay. Let's start with unselecting all by pressing U in your keyboard. Okay. Go selection, select special.
Oh, okay.
Make sure the hide unselected option is deactivated before unselecting everything. Okay.
Which one is deactivated?
This hide unselected option is deactivated. Activate this hide unselected option. Go and unselect all by pressing U in your keyboard. Go selection, select special. And here we will switch to members. And we will select members by its material. And it is steel. Now with the select special tool, we will select all member elements with steel material. You can click select objects. And close. Now you can activate this hide unselected option. While only girders are shown in the graphics view, you can use U in your keyboard and unselect everything that's shown to you at this moment. And then you can get select graphically tool and you can select first girder at the rightmost of the geometry. It will be the bottom girder when you look at from the top plane. And after selecting this first girder, you can click add group button and rename it as girder 1. We didn't define any folder. We will. That was your question? No. We didn't define a folder yet, but we will group the girders into folder later. Let's see. let me create the other ones. I think you did follow the process. You can create the rest of the groups for the girders. Try that one. Okay. So one of the questions was, can we change the order of groups after we define them? So when you define groups and structure groups, sorry, I think I'm just answering your question. Excuse me. I'm just trying to explain your question. So as we define structure groups in the Explorer, it also appears in the spreadsheets. So everything we control in the Explorer also can be controlled in the spreadsheets. So this is Explorer, structure group Explorer, and input data, structure groups, you will see their spreadsheet format. And you can actually create group here. I created a role and it appeared here. So I'm not sure if it will work, but probably if you add something here, no, it will not work. It should, I thought it will be upside, but no, I think in that case you cannot change the order in the Explorer. So can I? No, maybe it's just if I change it, no. No, you should check the order first.
Kind of like missing group one and it automatically.
No, I created manually just a second ago. Like creating girder one group. Did you miss that part also?
Yeah, I even group. It generated group two, but I don't have group one. I even didn't by what I think the procedure first time, and then the automatic show group two.
It's not
a
a
start.
That's a default.
Well,
That's different. There are some. I added group 3, 4, but I haven't entered anything. But
so when you click on add group button, it creates group always, and it renames it automatically.
yeah, but the first one, this first I created, but the automatic call group 2. There's something missing.
Yeah, because this is the first one.
This one?
Yeah, it's automatic naming. Just name it. You can change that name.
Oh, okay.
Okay. So after defining structure groups, now we can create a folder. Here in structure groups Explorer, you can click add folder and rename it as girders. And by dragging and dropping, you can bring this girder groups inside this folder. Just drag and drop into the folder. Okay? And last one is selecting the rigid members. Well, again, we can use select special tool for that. Before using select special tool, deactivate this hide unselected option. Make sure you unselect everything by using U in your keyboard. Okay? Then go selection in the menu, select special. And here we can switch to members again. And this time we want to select members with rigid material. Okay? Okay. And you can click select objects. Then close. then you can hide unselected and see only rigid connection members. Okay? While only the rigid connection members are selected, you can click Add Group button and rename it as rigid members. So if your group is created inside this girders folder, you can just drag it out. Okay? Is there any question? We have a question. Okay.
Did you select widgets? No. This is local selection, select spatial, then say geometry members, geometry, and members, and select rigid members. Members with property, just click material, and value should be rigid members. Here we are trying to select them. You just click select, select, you just click select, yeah. This one will select rigid.
I have several groups, but
Okay, I'm coming.
how do it just copy you? I think this one may be right. You could check, but I added root 2, 3, 4, and the region member. How to sign all information? Okay, like,
Do you want to read it?
no, I just wanted to let you check if each group. Yeah, I think group 1 is okay.
Oh, this one includes both shells and members.
This one nothing look like, right? That's why how do I, yeah. All the rest was nothing. My question, how do I get group 2
Okay.
to fill it? Yeah.
Let me just create them again.
Yeah.
I will just delete these.
Okay. You reach, yeah, and then just do it one by one. Okay, yeah.
Yeah. I can also use the spatial. Three.
Okay.
Three. Then I will just select members. And selection, select member join.
Yeah.
So
Yeah, yes.
members. Then I will put
Yeah, you.
then we will drag a window for border one.
Right.
This is
Sometimes the balance
view.
between.
Unselect.
And then the second one. Yeah, okay. And, okay.
I'm pressing view.
Yeah. And then before you select another one, right? Yeah.
These are borders. You can name them.
Yeah.
Then we will see everything. Unselect everything and just select your selection.
So, okay, I think we all at the same page.
Yeah, okay.
So we will not forget.
Right.
And we also have unselect and select just numbers. Spatial selection, numbers, section or material should be
Okay.
select and tools.
Yeah.
It's
a lot of people.
Right.
This is correct. We will say group rename group.
Okay.
This is fine, and the other group you can
Okay, at this point, if you want to switch to the checkpoint,
Oh, thank you.
we are at in the resource folder. You can just go open fourth model structure groups, 4 structure groups. We are at this point now. For the later steps, you can use this model to follow me, okay? Okay.
Yeah, okay, thank you.
Okay, now we will create some cross frames between girders by using a macro. So at this point, please make sure you completed the model up to this point. If you cannot completed, you can use the checkpoint model for structure groups. And make sure you only have one LARSA instance open in your project. Make sure you have only one model, one LARSA instance open in your machine. Now you can check your task manager if you can, and make sure there is no other LARSA is open, just one project. Okay? So now macros are little programs that we can generate as a support team to communicate with LARSA 4D. So through VBA macros, we can communicate with the LARSA 4D UI, and we can enter some tasks. We can automate some tasks. We can enter inputs with macro to LARSA 4D spreadsheets. Okay? Or you can extract results from LARSA to your spreadsheet through macros. Now, we will see an example to input cross-frame to the model with a macro. So now, in the resource folder, you will see this cross-frame generator. Okay. You can open this macro, this file. We are at page 47, by the way.
What was that file? 10?
Cross-frame Excel file. John.
What is this?
It's not
What are you looking to
opening.
open?
It's not opening.
LARSA? Or the
I think
Excel?
we have many things here. Can I close
Yeah,
this
you
one?
can close all that out. You can close everything. Just close all windows.
Not
You don't
sa-
have to
I
save
will not
anything.
say.
Mm-mm.
Okay. Okay, I already
This
opened.
one is also showing security risk. Right click and unblock.
Huh, it's not like that in my case, but in their case it's like
Yeah.
that.
Can
It is not like that in my case. Uh-huh.
Do you want to
okay,
try
let
on the
me
other
check.
laptop?
Let me check. I will check.
Uh-huh. No security in my case.
It's happening.
Sometimes it says disabled and we should unblock something here. But it's okay in our case, but it's not
Let me
opening.
recopy the bottom.
Why it's not opening?
You want to try using the
If you run it off the flash drive, it works. Yeah.
I don't understand. This is something to do with
It's security.
security.
It's a great Vita.
Oh, okay. So maybe we cannot generate.
No, it'll run off, they said it'll run off the flash stick, so.
Yeah,
try
we
it.
will try to run from flash if it works.
From flash, from USB.
Yeah.
Okay.
We will try that.
Try it.
Try it.
Also, I cannot open.
Generator, let's click the generator button.
What? I cannot
Maybe it's
close this
something
one.
up
Can
there.
you
I'm not sure.
try?
Security lights working fine. I'm not even, some of us must be trusting them back, that must be. I don't know why you and I be on the list, but you know.
The higher you go,
Oh,
the more
okay.
trusted. The lower, if you are the lower end of the ladder.
You know what, in my case, I would have died. Seems like remote.
File from where?
Their list spots.
Oh,
And Mark, are you typing in?
I notify an object.
Oh, I said it perhaps.
It will say all done when it finishes. The exam will say all done. That's what we
I just right now. I'm hard for.
This is a screen from 8 LP by 2. Hey, Lord, I know thinking.
That's what the message is kind of find object. You generate like that, yeah.
You still had it? Did you run it?
It doesn't work, that's why. That's come out with this. Yes,
Scroll all the way down.
Okay, let me see.
Okay.
Tomorrow, I
No,
have
we
this
have
up here.
a lead-up problem here, security. Something to do with their security.
Yeah.
We are not able to run macro. We will skip cross-frame generation. Okay. But anyways, tomorrow I will show you how to generate
Right.
these elements.
Okay.
Oh, maybe I open from.
Maybe we can create in our computer.
Yeah, hold on. Yeah, I see.
Maybe we can
Yeah,
create
open from,
in our computer.
You try it and see.
Okay.
But we're all on the same connection here. The Wi-Fi.
It's because of the Wi-Fi. Okay.
It might be.
So let me try to create on my end. But I don't think it will happen. But let's try. So to make the macro work, we need to specify some inputs. So this macro creates member elements by using LARSA element library, and it will looks at the input. It will look at the input you define for the first and second girder. So you will define the girder, two girders, that then the cross frames will be generated within between two defined two girder group, and we define this two girder with specifying structure group name. So naming is important. So here, if you created girder 1 and girder 2 with this naming, and if you want to create cross frames between girder 1 and 2 in the Excel sheet, you need to have exact naming for the group. Okay? Otherwise, it will not find the correct group. And also, yeah, I just explaining. Maybe we can. Should we totally skip this one?
Maybe
We can save sometimes. It's up to you.
I think you can skip the macro part. I will still talk. I will talk about the modeling techniques, cross frames, and we will generate them together tomorrow.
Okay,
Tomorrow.
let's skip this part then because it's not working in your case because of security. So let's skip the macro and go another checkpoint. This time we should all switch to a new checkpoint model, okay? You should save your models, your own models, and close it at this moment. Okay.
And we'll got the USB. Then we can do it together.
That's local already.
Local? Okay.
Oh, but it's just only generated one.
Yeah.
The others.
Yeah, that will be, yeah.
Laura, how are you time-wise?
We have substructure generation and analysis. And we have 2 hours. And I think we will make it.
And stage construct, yeah. That's part
Yeah.
of the analysis.
Yeah.
And which one did you open?
I opened 5 cross-frame generation. And now it should have cross frames.
Laura mentioned too, for anybody that does get lost, you can see the file name on the top left.
Yeah.
The program will
Yeah.
always be in display.
Here. File name is here. In your resource folder, you can find this 5 cross-frame generation LAR file. Not this one.
Close.
And we will use this model for the rest of the training, okay? Because it has cross-frames already. Okay. So now we will create substructure. For the peer 1 and peer 2, we will have a peer cap with rectangular cross section, and we will have peer column with circular cross section. Now we will create a database. We will update our section database to have these cross sections in our model. Okay. So I suggested to open this this model, but we will close it now and just open the section database, because it's not a good idea to connect the database together with the model. Okay, let's close this one also and open our LPSX file, bridge design example section that we just created previously. Do we have question? No? Okay. So, what page here? Page 49.
Substructure, right?
Yeah.
I thought we call open cross frame.
Yeah, we skipped that part because macro is not working on your side.
Oh, I saw you open your file, maybe. Okay.
So, we're gonna go more.
Wow. Yeah, last one, but
He's opening you would modify that from their spreadsheet.
okay. So now you created a section previously and save it as basic bridge example section. You can use that one. I couldn't find the one that I created. I couldn't locate the directory. Can you help me? Which directory?
This bridge, physical bridge example section.
I created it. It's different than this one.
Which one?
Different than this one. I don't remember. Do you remember?
Which one? Which one? Which one?
That we just I saved my model to a directory, but I couldn't find it now.
Then just select the mouse.
Maybe. Okay.
This one.
Yeah, that one.
Okay. The items is unavailable. Why unavailable?
I don't know.
Why unavailable? Let me see. I will try to find recycle bin. Open.
We don't need to change.
Your model is not removed. I'm not able to find it anywhere.
Okay, we don't
No.
need it. We don't
Oh,
need
okay. Okay.
it. Just let's continue with the existing one.
Yeah.
Okay. So everyone can look at basic bridge example section LPSX file in the resource folder. So it should have cap beam and pier column. You should see that one. Okay. So
So we open that file, right? Basic bridge is example
Yes,
section.
that one.
okay, so now in this file you can see that the cap beam and pier column section is already generated. I have generated these sections previously, but I want to show you how to create the sections. So we will just create an additional section here and we will then delete it, okay? Because we will follow the training with the checkpoints later. That's why we need to use this section composer file. Okay. So previously when we added a section for the cross girder from the database, it automatically created a section composer file in the background, and it puts this eye girder that we select and we enter we entered its values. We updated the depth, width. Do you remember that part? Okay. So you get a template in the LARSA 4D environment and you fill the templates by updating the section parameter values, and then in the background we create this section composer file and we connect it to the project, and then you can use the section composer file to enter the other sections for your model. This is what we are going to do now. It's already cap beam and pier column is already added here, but you can follow me to addition of one of these sections. To add a new section into the database, you can, first of all, you should close the LARSA 4D. You should close your project because it's connected, this LPSX is connected to the project and it will...
We have several issues here.
It's not working that one.
What?
Yeah, when we try to add a section, some computers it throw an error message, and we also reach maximum
I think
number of
maybe what happened,
users.
everybody closed and opened
Yeah,
too many
close and
times
open,
too soon.
So we just exceeded the user limit here.
I think people then opening the lessons and not closing the other instruments.
That's, yeah.
Can we just define the circular pier and the cap in the main LARSA environment?
Defined already. I was just gonna show them if we can skip that one also.
Really?
It's already defined. You don't have to modify.
Okay. Okay.
Let me see something quick.
But everybody should just close all LARSA instances because we reached the user limit for some reason. Maybe we can close and...
Okay.
Let's just close section composer file and LARSA file.
People to remote here and they open multiple LARSA.
Maybe.
Take a lesson.
Multiple.
Not art. I mean, maybe people virtual. Yeah.
Oh yeah, maybe
Yeah.
also.
Tell them maybe
Yeah.
not art. Yeah.
Can you check also the Teams chat?
Yeah.
Section composer doesn't work, they say.
Yeah. This can be also the security.
Okay. So
I'm not
I don't
sure.
know.
We will figure out later. Okay?
Okay.
We will figure out after today's
We
training.
have license available.
Let's see the chat.
So does that mean
Never
we can
worked
play with it now?
this morning.
Okay, so let's not spend time, and I just quickly show you how to define section if I can open it. So this is section composer that I mentioned in the beginning of the session. Okay, you don't follow me at this point, you just can look.
Yeah, can you show from beginning?
Sorry?
Can you start beginning from here?
This is,
New section?
this is
This is
fine.
beginning. Oh, beginning.
Okay, so So as I mentioned, we created a section already within LARSA 4D, within the project file, and it automatically creates a database, and database is a section composer file, and you can also add new sections inside the section composer file. So it's a kind of an empty canvas. As you can see, you can draw some shapes here. Okay, this is a way of entering a section. Or you can use databases here as well. You can go section, add new, shape, standard shape, and it will open the database we just seen while we are creating our girder section. The same database also works here. So you can bring sections from templates here as well. So for the peer cap, for example, we include a basic rectangular section, and we enter its values based on our project requirements. And you can add it to the canvas, and you can make modification here in the section composer, and you can see the values here. You don't have to change the parameter values while bringing the section. You can also make modifications after bringing the section, and you can see that we have parameters for the section. So when you switch the points, this section is defined. The points of this section is defined dependent to the parameters. It means that for every change, you don't have to change the point coordinates. You just change the parameter values, and point coordinates are automatically updated. This is how we create section in section composer, and this was what we were doing. If you can open section composer, we just try to bring rectangle, and we will go section, add new, and we will add another section, and it will has another geometry. And for example, a circle, solid circle with 40-inch radius. Okay, so now I have two sections. I can add more than two. I can have many sections here, and I can connect this database to a model, and for many models, and use it multiple models. Okay, so this is how we define section databases. So let me close this one. And now at this point, so can we open models now? Okay. Okay. At this point, let's go to substructure. 6.1 substructure properties. Okay. Okay. Nothing here? Shema, can you look at that? Okay. The others can others see the model? Do you have model? Okay, so you have model. Okay.
We are having 3 pages of
What page are we on?
on practice. Each page we are following.
Now we are at page 50. Now we are going to define our peer cap, okay? So in our model, let's switch to simple rendering by going graphics, simple rendering. And look at from the front plane. And unselect all by pressing U in your keyboard. Get the select graphically tool and select the support group between first and second span. Between first and second span. This one. No, not the group in the Explorer, but I'm sorry, maybe I should say this way. Select joins with the support between span 1 and span 2.
Well, it's press U on select, right, and then go to the toolbar.
You after unselecting all, you can get select graphically tool.
Yeah.
And with that tool, you can select support between span 1 and span 2. And in Model Data Explorer, you can see that 4 joins are selected. You can unselect all by clicking U, pressing U in your keyboard. Get select graphically tool and select support between span 1 and span 2.
Okay. Select the second support.
Second support, yeah.
Just select the second support.
I'm caught up for. I'm on it, bud.
Go to here.
And then this one.
No, I'm just going.
Okay. So
Yeah, go to here.
in the
right?
Model Data Explorer, you should see 4 joins are selected. Okay.
Oh, I see that one.
And then you click it and it'll give you 4 options.
And now you can click hide unselected option. And you can switch to 3D view. Now let's open join spreadsheet. We will go input data, geometry, and join spreadsheet. At the join spreadsheet, at the bottom, you will see show only selected objects. Activated. Are we okay at this point? Okay. Then copy the join coordinates for the selected joints. Just we did before, the same way. Inactivate show only selected object option. Go at the bottom of the spreadsheet and for the X station of the empty row, right click to it and say paste. Okay, so we will create another joint group and we will update their vertical coordinates. So now for this 4 joints, just highlight them. Okay, right click to it and say apply formula.
Okay.
Just for the 4 cells that we just paste. Okay, and this formula is the value, the x minus 2.5. So we will create joints 2.5 feet below the other ones. Okay. Okay.
Click on
Okay.
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 And then click OK. Yeah.
I felt your footstep from here. I like that.
So let me see.
Go through the doors, turn back.
So you should see something like that in your graphics view now at this point. Okay. And let's go back to joint spreadsheet. Now we are going to create 2 more joints for the overhang of cap beam, extensions for the cap beam. Okay. And we will add 2 more rows in the spreadsheet. Okay. You just double click on the empty row and it will add 2 more joints, and we will update these coordinates now. So the x coordinates and z coordinates is going to be the same as the last joint, this one. So the x coordinates will be 100, or you can just copy and paste here as well. And z coordinates will be the same. Okay. And we will just update this y coordinates. Now we are giving extensions in transverse direction to the cap beam. Okay. So the first one should be -2 and second one should be 38. Okay. Let me see. So we didn't create any members yet, but the joints should be look like this. Okay. So these will be extensions. Okay. Are we okay?
-2 and 38.
I couldn't find my spreadsheet.
Input data geometry.
Geometry.
Okay.
Oh, thank you.
Okay.
Let me see. Why the view?
Now let's draw cap beam. You can close spreadsheet now. So don't lose your selection. Be sure your selection is like this at this moment. Okay. Now, by getting this unselect graphically tool, we will just unselect joints with the restraints. Okay. This way we will just have joints for cap beam. Okay. Now, after unselecting the joints with the restraint, you can take draw tool again. In the main menu, while the graphics view is active, go to draw, geometry, members, and now we will draw a single member, not multiple member, because I want to show you a tool for meshing. We will draw one member between the first joint, the leftmost joint to rightmost joint. Okay, single member. So I didn't select the section and material. I can do it later, but if you select it, it's good. We should select it. So I didn't select the material. I will edit now. So let's close this draw members tool. I will go input data, geometry, members, and activate this show only selected members. And here in spreadsheet, I will select cap beam for section start. I will leave section end as same as start. And I will assign FC4 for cap beam material. Okay? And then you can close spreadsheet. Let me see, I think also we need to define orientation angle. You can define orientation angle in the spreadsheet also, or in Model Data Explorer, you can enter orientation angle for the selected elements, and you can apply changes by clicking on the check mark. Okay? So let's switch back to simple rendering. So now we have a single member, and now we will break member to existing joints. So to do that, I will go modify members and select break members to existing joints. So if you use this shrink option now, you can see that there are multiple elements representing the cap beam. Okay. Now to connect the girder and cap beam, we will create rigid connection members between these two joints. Now, let's see. First, I will get rid of this restraint because I will define explicit substructure there. I don't need this basic support anymore. So to do that, I press U in my keyboard and switch to side plane. Sorry, front plane. And I will get graphically selection tool and select the joints with restraint. And in Model Data Explorer, when I switch to joints, I see 4 joints are selected. And I remove the restraints and apply changes. So when you switch to, I selected the support, joints with the support, and in Model Data Explorer, I switch to joints, and I remove the restraints here. And I click on check mark to apply changes. Okay? Are we okay?
Say that last step again.
Sorry?
The very last step. So we select
Very
all
last
of
step is just unselect these restraints and click check mark to apply all changes. So every time you made some changes in Model Data Explorer, you need to click on check mark to apply changes. Okay?
So what are the restraints which are being removed?
Sorry?
What are the restraints which is being removed? You're removing the restraints, right?
Yes.
What are the restraints there?
Now we don't have any restraint. We will create a rigid connection member between these two, and it will be, we will have girder this way, we will have cap P, and we will have column, and we will fix the bottom of the column. And we will have fully fixed city at the
So this is the restraint at the top we are removing, modifying.
We are, the translation direction. We just remove the restraint in translation direction.
Yeah, at the top of the phone. Okay. That's the top of the phone. That's your removing, right?
Yeah, it's bottom of the girder.
Bottom of the girder, yeah.
Yes.
Oh, 2.5.
So with this step, we remove the restraints at the bottom of the girder because we are defining piers explicitly with its geometry. So now let's draw rigid connection members to connect cap beam and the girder. So let's so okay. So let's switch back to 3D view. Unselect all. And you can graphically select these cap beam, okay, with its joints. Go to group and click add group button and rename it as pier cap. Okay. And now with the graphically selection tool, let's select the other joints. These joints are the joints at the bottom of the girder. Okay. So now since these joints are belong to girder and the others are belong to cap beam, with defining rigid connection members, we will connect girder and cap beam. And to do this, we will use a draw tool again. Go draw, geometry, members, and this time let's set the material correctly, section and material correctly. The section is going to be rigid connection and material is going to be rigid material. Orientation angle is not important because we entered the same material properties for moment of inertia for both directions. So section properties, sorry for that. So let's now draw members. I will start again. Something is not correct in my case. I'm not sure if you can draw. Did you draw? Can you draw? I will start over. Something is wrong on my end. I selected everything. I go draw. Geometry, members, and I get I will set section as rigid connection and material as rigid material. Okay. And then I will click on join to joint. Okay. Joint to joint. Okay. And then you can close. Now you can go group and by using this pier cap group, unselect the pier cap. Okay. And then you can go graphics, selection, select joints of selected objects, and you can have joints included for the rigid members. And you can add another group here with this current selection and rename it as rigid cap rigid connection. Okay.
Okay.
Now let's create our columns.
Okay.
Now column, we will have two columns. The first column will be in the middle of this member, and the other one will be generated in the middle of this member. So for that, it's better if we mesh this cap beam. So I will unselect all, get this selection tool, and select these 3 members, and go modify, break members, and for each member, I will leave number of segment as 2. Okay? Okay. So now, so
just a curious question.
Yeah.
For the middle member, we are not putting a column over there.
But we
still
mesh
want
it.
that.
Yeah,
Is there a
it's not
particular-
necessary actually.
Okay.
It's I just to have uniform mesh. I prefer to mesh that one also.
Okay.
Second one?
So so don't follow me at this step, but let me just show the complete rendering of the column, the cap B. So now we will create a column at the bottom of the peer cap, and to have that, now as you can see are the let me see, the joints are at the centroid of the cap B. So to have column at the bottom of the cap B, I can apply membrane offset to the column after generated, or I can create another rigid connection member that represents the half of the peer cap depth, and I start my column. I create my column by using that joint that I created with the rigid member. So this is what we are going to do, but there are other ways of modeling these section depths. You can use membrane offsets as well. Let's follow the manual and create rigid members. Again, this time we directly use drawing tool. Let's go again, draw geometry members. Here you see 2D plane. Let's switch to global XZ plane. And activate this length and enter 2.5 feet. And activate the direction, enter 90 degree. Now we will draw elements, and when we click on a joint, it will automatically create a member length, and this length is equal to 2.5 feet that we just entered. And you can just click space, and it will be in global XZ plane, and the angle will be 90 degree, okay? And I will create another column here. So I create a connection member here. So I already selected this material and section, so it will apply automatically for the last, for the next drawing, okay? So let me close this one and unselect all by you in your keyboard. Get select graphically tool, select this new rigid connection members, switch the groups, and click on this cap rigid connection and click add selected geometry. Okay. Okay. Now we will define peer columns. Okay. It will be the same way, actually, the same way. We will repeat the same way for the column. We just change the length and section, that's it. Section and material, and that's it. Now I go draw again, geometry, members, okay, and it will be again XZ plane. This time length is going to be 40 feet and direction is going to be 90 degrees. And set the section to pier column in the Model Data Explorer in the right hand side and material to FC4. And since it's a circle, 0 is okay for the orientation angle. Okay. What happened? So let me try again. I have sometimes have some problems with this draw tool. Which is okay. And after creating these columns, you can close the draw group, a draw tool, and you can unselect everything by using U in your keyboard. Select the peer columns only, 2 columns, and go to Groups, Structure Groups Explorer, and click Add Group button, and rename it as peer columns. Okay. So now we will again unselect everything with U in our keyboard and select only the bottom of our column, and we will define restraints here. So to do this, I will use Model Data Explorer. I need to switch to joints, and here I will define full fixity in all directions at the bottom of the column. Okay? Let's see the full model by deactivating hide unselected. Now I have a substructure here, substructure geometry. Let me see. Incomplete rendering. Okay. Now I want to have substructure geometry in this part as well. So let me close this shrink. Okay. Now I will copy the pier geometry to third support location between second and third span. So to do that, first I created group, structure group, folder, structure group folder by using this add folder button in structure groups explorer, rename it as peer, and I just drag and drop components, peer components into this folder. I will go to simple rendering to see the selection clearly. So instead of selecting groups separately, I will use the folder now. I will click on the folder and say select and unselect everything else. Then I can hide unselected and see which elements are selected. Okay, so Now we will copy this one. Let's go draw, generation, repeated copy, and here we will set delta x to 100 feet to create a copy 100 feet away from the selected geometry. Okay, this was our span length. And make sure you select this merge duplicate joints option. And also it's not like that in screenshot, but please select this update existing groups with new elements option. Don't forget to include this update existing groups with new elements option. Okay? Okay. Let's click OK now and see our geometry. Okay, the second pier is created, but the bottom of the girder has restraints now. We need to remove those restraints. So let's look at from the front plane again. Unselect all with the U in your keyboard. Get selection tool. Select joints with the restraints at between second and third span at the bottom of the girder. And in Model Data Explorer, in joints part, remove the restraints and make sure you check this apply changes.
Can we have 10 minutes, just a few minutes for just making everybody?
Mm-hmm. Yeah, sure.
Maybe you can also help me.
Okay, sure.
Okay, let's just make sure. Okay, we just started from the same point, substructure.
Oh,
Pier column.
We are there.
Okay. Okay, so you were in the side view.
But I was trying to get here.
Oh, really?
I was trying to get here.
Okay, so we have pier column model completed.
Yes. Yes. If you open that
I
one,
don't need to copy.
yeah, you don't need to do anything.
Okay.
I think it's time to take a break.
Let's take 10 minutes.
Okay.
Yeah, let's just take a break.
We should just notify the merchant we're 10 minutes that we
Okay, we are going to take 10 minutes break now. See you in 10 minutes.
your all faces, and I really hope you get a lot out of it. Secondly, because we're on the executive suite, the main doors lock at 4. So we are only able to exit this building now. We are not able to get back in. So please keep that in mind as you leave the rest of the day. And then finally, planning for tomorrow, so we can just finish the rest of the day and then go home. In person, we'll be in the building right across the street, across the bridge, the Monroe building. We'll be in training room B. We'll be in room B. Everyone must sign in. This is not a VDOT building anymore. It's run by DGS. So we have to all sign in, even though we have VDOT badges. I think that's it.
That room is the same floor.
It's the first floor, and it's one of the rooms, I think, it could be one of the rooms that we've donated blood in before. They have blood drives in there if you've been in that room before. But I'll be standing around in the lobby directing people, and you'll probably see us all. So same time, and we'll probably be leaving a little bit earlier tomorrow, around 4:45. As the building closes at 5 o'clock, and we have VDOT badges and not Department of Education badges. They want us out there by 5 o'clock. That's all I got. Any other questions?
I know you all have plenty of questions.
So many questions. None for me? Then I will give the floor back.
Thank you. Thank you again.
So we'll just acknowledge that we're going to adjust a little bit.
Okay. So now,
We all on the same page with the same model.
so okay. Now we are going to use bridgepad coordinate system to convert back to our curved geometry in the beginning. We converted to straight geometry to simplicity of modeling and simplicity of selection.
Just one thing before we start. So we're going to make a small adjustment in the schedule today to better use our time together. So there are two very large main topics that are part of this introductory training for new users. And that includes LARSA's stage construction analysis and LARSA's influence surface-based live load analysis. So what we're going to do, because we don't want to rush any of those topics, either of those topics, we're going to end today's session with the next segment that Delar is going to conduct. And then our last section today is going to be influence live load analysis, which I think in our official agenda is the second to last topic. So the stage construction, that's also utilized by LARSA Steel Bridge module tomorrow. I'm sure this is very detailed, the training today. Once we get into LARSA Steel Bridge module tomorrow, it has a very friendly interface to it. And a lot of these more complex topics for influence live load, stage construction, it's going to be a much simpler illustration to see how those topics are applied. But we don't want to rush those explanations today, so we're going to move that into the start of tomorrow's training session. So just to let you know that. So we are going to move over a little bit of content in here, make that adjustment, and then we'll integrate that to tomorrow's session.
We'll start still at 9 o'clock.
Excuse me?
Start still at 9 o'clock. Right?
Yes, and we'll be starting tomorrow at 9 a.m. Okay, Delar? Okay, you're set. Okay, so yes, our page and then the model we're going to use.
Okay. So now, so we all set with the substructure generation. Now we are going to set our displacement user coordinate system. So let's convert to curved geometry now. Everyone, let's go to Model Data Explorer and Coordinate System. Right click to the bridgepad UCS and select Convert to this UCS. And you can use this Zoom Extends tool to see full geometry. Okay, at this point, let's look at the support directions. So we have curved alignment now, and as you can see, we defined restraints in translation Y at these joints, and they are supporting the structure in global Y direction now. So instead of supporting in global direction, we can adjust the support direction to adapt it to bridge alignment. So we can support the structure in bridge transverse direction. So to do that, we will define displacement UCS. So what we do is we will go input data, geometry, joints, and we will select this translation degree of freedom column. Just let's use this sort descending option, this one, sort descending. And it will show the joints with restraints at the top. It will sort these joints. So what we do is we will change the displacement UCS of the joints with restraints to bridge path coordinate system. So you don't need to follow me at this point. I just want to show you the graphics as well. So I will select joints with restraints. Okay.
Just watch the support direction. Now they follow the global Y direction. And
now
change the direction.
I will change to bridge path UCS and apply changes. And in graphics, you can see the supports are now in bridge translation direction. Okay? They are not in global direction now.
So you do not need to define additional Cartesian coordinate systems along your curved structure. You are just using bridge paths and you are just changing the rotation of these supports.
Why mine not show the curve?
Trying to be quick. Okay. Okay, let's continue. So your final geometry can be seen in complete rendering. Okay, so let's stop hands-on. Right, just a second.
Trying to continue hands-on maybe, or just.
Yeah, we can do it, but we can do it this linear static analysis together.
Okay.
Then we will change the model. Okay.
Okay, so we are going to do hands-on together.
Yeah, just linear static analysis with the full model.
Are you okay with their model, or can you come around?
Okay, let me continue for the others. Are you okay? Everything goes okay. So we will define self-weight load case now. In loads, you can switch to load cases explorer, and we will create a special load case now. It's called self-weight. You can create a load case button here. Right click to it, go to properties, and here you can enter self-weight.
From where?
You can go load cases explorer, add load case. Okay, right click to the load case, generated load case, go to properties.
The property in mine is not sure.
John, can you look at that? And after defining these properties, you can add a weight factor in vertical direction, minus the direction. Okay, and you can set the load class as that load. Okay, and click OK. So this load case will automatically calculate the self-weight of the structure by looking at the unit load that you defined for the material of the elements. Okay, and it will automatically apply to the structure for the analysis. So after creating this self-weight case, we are ready to analyze the structure. We now just do simple linear static analysis, but we will use this self-weight in stage analysis where we define our construction steps, form our construction sequence, and where we run time-dependent analysis to consider deck elastic modulus. So this is for tomorrow, but for today we just run linear static analysis. So if you create your sulfate load case, you can go analysis, linear static analysis, and click analyze. Okay.
Yeah, I don't see that.
Okay. So do we have anything in chat? Any questions maybe?
But we're not all at the same step yet here.
Okay.
Analysis
Good.
and,
Then.
No, those are questions.
Okay. Okay.
Okay.
Okay. Now, if you run the analysis without any issues, did you run analysis? Okay. Okay, great.
Okay. All right, top 10% of the room.
Okay, it's great. So let's see the results then. So we created a load case, sulfate load case, and its results will be appeared under this load cases heading in Analysis Results Explorer. You will see the created load case name. So this is sulfate. We named it as sulfate, and we can see results by activating this result case in the Explorer.
Well, could we just rerun it real fast for those that didn't get to that point yet?
Didn't get that point. We just analyze, and analysis results is automatically appeared here. I didn't do anything.
Run the analysis statically yet?
I think everyone can. Everyone did.
We need to just follow integrity check, because in the previous steps we just missed some of the section assignments.
Everyone did that. Maybe you can just go checkpoint linear static analysis. Okay. So, to see the results, I will activate this sulfate load case, and let's see the deformed model. Make sure everything is selected by pressing S in your keyboard. Okay? Activate the result case, and these are our graphical results options. Let's activate deformed model. And you can play with the scale factors. Okay. Scale factor is at the bottom of the Analysis Results Explorer. So don't worry, this is the last part. We will change the models at this point now. No. So I used 181 for scale.
There we go.
No, they are okay.
Yeah.
Okay.
Here.
And
Like stupid scale
and this is graphical results. And you can also see spreadsheet results.
I don't have the one that leans. So yeah, that's the one.
Let's see spreadsheet results now. To see the spreadsheet results, we can use this result case, right click to it. For example, we can go joint reactions, and these will be your spreadsheet results, okay, for the selected joints. And you can see other results, member end forces, member sectional forces, stresses, etc., and shell results as well. Okay, this is how we see the results. Now, Now we will change our model and we will open another model, okay? So everyone can save their model, close it, okay? Close it.
Okay, so everybody can save their model and close it. This point. We will now start the live load analysis discussion
Yes.
with another model, save point, right?
Yes, yes.
The number of the save point is 9.
92 LL surface.
Okay.
And what page in the training guide?
And we are at page 71.
Okay. We're on page 71. 71. Yeah. And we will start with this 9-2 LL surface project file. The live load discussion.
Okay. So let me see. Okay. So now we will perform influence surface analysis. In LARSA 4D, we can perform influence line analysis. It's possible you will draw 1D lane on the deck shelves, or you can draw again 1D lane on girders. So, but it probably requires to manual drawing to consider multiple lanes loaded cases, and you need to create multiple load combinations. So instead of doing that, we usually prefer to conduct influence surface analysis, because with the influence surface analysis, everything is based on the algorithm. Everything is up to algorithm. You can, of course, you have some controls. You can define some conditions for the algorithm, and the algorithm will find the critical locations, vehicle locations in transverse location. In transverse direction, and it can locate the lanes to the critical position in both transverse and longitudinal direction. So it will save lots of time.
So this is part of what we were looking at, that we're reinforcing and discussing earlier at the start of the day, how that algorithm works on the back end for us is influence surface. But the one thing that I want to mention, that the reason we're bringing the stage construction tomorrow to reserve more time for the influence surface-based live load today, this particular feature is a very significant feature with VDOT that's very critical, with the reason why the mandate is in place for the modeling and the rating of complex spans. So this particular analysis that we have, it's very important that we really understand that algorithm on the back end that we looked at today and the way this process works.
Okay, so I was planning to generate this surface together, but we don't have that time, so I will just show you the end input for the surface generation. So for the influence surface analysis, we have 2 steps. The first step is defining surface on the deck, okay, 2D surface on the deck. And in the first step, we also define load case, and we pass a unit load on this surface with a certain interval. And we do it with moving load analysis. This is the first step. And the second step is creating influence-based result case. It's a post-analysis procedure. In the second step, we will enter some conditions for vehicle placement. And these conditions is based on your design requirement, based on H2LRFD. Okay? So now, for the first step, first you create a surface. So this is how you create surface. Don't follow me. I will just show you how to do it. In Model Data Explorer, we can open this lanes and surfaces part. Just like creating bridge path coordinate system, we can add a new lane here. And you can go path spreadsheet, path and view. And it will open this spreadsheet. So here we will specify geometric control points for the center line of the roadway, center line of the surface. So you just create a center line. So this could be curved, okay? So if you have curved geometry, your center line will be curved and your vehicle will follow the curved geometry. And so this is by entering geometric control points on reference elements. For influence surface analysis, reference elements should be shell elements. And here you will see some span marks. For the span marks, you will generate the exact geometric control point, geometry point. And after that geometric point, you will create another row and say span mark. And it will be your span location, the location where your span ends. So you will tell the influence algorithm the span location this way. And influence algorithm will know the span location and it can place the vehicles to the critical location by considering these spans. Because in H2RFD, we have a requirement for that. For the negative moment case, we need to place two vehicles back to back on one lane, and these two vehicles should be separated into different spans. So in that, to consider this case, we need to give the location of the spans to the algorithm. This is the way of entering spans. And after creating this center line, then in input data geometry, you will see this lanes and surfaces tab. Here you should enter a width, and this will be your roadway width. And we need to create an influence load case. Now you can follow me at this point now, okay? To create a load case, I switch to Load Cases Explorer, just like creating self-weight. I click on Add Load Case button, rename it as Live Load. You can go to Properties and change its type to moving. And you can double click to it. So it's not like a self-weight load case. We need to enter loading in the spreadsheet, okay? Double click to it and it will automatically open the spreadsheet. So you will see moving loads tab here. You will see all other loading types and you will see moving loads here. You can click to it. It's possible to move a basic moving load, okay? It's you can just pass a vehicle on a line. This is possible, but we are going to perform influence-based live load analysis. That's why we need to switch to influence loads. And here we create a row by double click on it, select roadway, and here you will specify applied load direction. Now we will consider the vertical effect, vertical vehicle loading. So that's why the applied load direction for the unit load is global minus Z. And here you will specify an increment. So for this case, let's enter 5 for forward increment and 3 for transverse increment. So it means that on the surface that we just generated with the width, this unit load is passed by considering these increments that we specified. So the unit load will be generated will pass in forward and then in transverse direction. And LARSA for the moving load analysis, it will be performed with the moving load analysis. For each unit load location, we will record the response of the structure, and these will be influence coefficients. Okay, we will generate influence coefficients both longitudinal and transverse direction. Okay. So now we have live load, influence-based load case, influence load case here, and we can run the analysis.
Okay, how can we add lane load?
Sorry?
Lane load.
Lane load. We will define lane load after the analysis. It's in post-analysis procedure. So we will define that lane loading in influence-based result case. Okay? Maybe I should rename it as influence coefficients as in manual. Okay. After defining this load case, you can go analysis, static moving load analysis, and click analyze. And yes, save project.
I need to get two cases. There's my three.
Yep. And you can change the top. Just none. Just a none.
Oh.
For 49.
Yeah, that's service. Oh, okay. I need a new opening file. Yeah, I see. Okay. Yeah, right. I was up here. Right. Yeah. Like log, what the influence, what the crystal, yeah. Yeah.
So,
And
you know that
right.
Yeah.
Okay, standing room, okay. And I, yeah, you can be.
Yeah.
All right,
It's
thank
all
you.
sort of. We have the unit of big and and of course this is okay. Let me mention one thing.
It's maybe related. So we specify this unit load spacing, and so we get the response of the structure at certain points with the specified increments, right? But the vehicle in the post processing, when we define the vehicle placement, can fall between two influence coefficients, not just exactly the point that we just defined. And we find it by doing linear interpolation. Okay, so if you have a small increment for the influence coefficients, it means that you will have more accurate results. Okay, but it's maybe. What?
What is the warning message there? Can you read that?
This one? We didn't connect any database yet for the vehicles. We will add it. It usually we can edit before or after the analysis because we need those vehicle database for vehicle placement, actually for the post-analysis procedure.
Do we have a plot of this surface?
Plot of surface.
Yeah. Can you visualize the shape? Yeah.
Just the surface for the vehicle. Both. Yeah, we can visualize everything, by the way. But we can visualize the surface on the deck, and we can visualize the vehicle placement also. All right, so analysis is finished. After the analysis, you will see this moving load cases heading in the analysis results explorer. And under that moving load cases part, you will see influence coefficient group. And these are for each station with certain increments and the offset is transverse offset. So these are result cases. The structure response under unit load at different locations. And you can see results, all results from these influence coefficients, the effect of the unit load. By using this influence coefficients, our influence algorithm finds the critical vehicle positions. Okay. So now we can continue with the post-analysis part. So for the vehicle placement, we need to know the vehicle models. And we get this information from database, just like section database or material database. Now we are going to connect H2 standard vehicle database to our model. To do that, please follow me. You can go input data.
And Laura, just to re-verify for the question that we have on the Teams chat. So
do
can you
we-
just re-verify the analysis that we just ran, the analysis type that we just ran?
We ran static moving load analysis. Okay, so to connect database, we go input data, connect databases, connect standard database, and you will see this H2 vehicle patterns.
Can you repeat that? Can you go back?
Sure.
Connect is, I don't see connect standard database.
Here's okay? Okay. Connected database and connect standard database
And then we
and select H2 vehicle patterns, DML.
ask
And click open.
up one, right? And then you go open that.
Open. So now it's connected to your project. You can use it in your analysis. You can click OK. So let's view this database. I mentioned the database editor. Now we will open this database in database editor. To do this, I again go to input data, edit databases.
Edit database.
Yeah, edit databases. Okay. Okay. And here you can navigate the vehicle models. You will see, for example, this is HL93 2D design track. This is the design track from H2LRFD, the required track for the design. So it has magnitudes, the axle magnitudes, wheel magnitudes, axle spacing, and everything. And when you switch to graphics, you can see the loading in graphics. And you see this variable axle spacing. This is a requirement of HDLRFD. What? Yeah? All right. So, H2 requires to have variable spacing for the rear axle.
Oh, here,
So our influence algorithm, with this input, we can satisfy that. We will enter different inputs for start and end location for the rear axle. And our algorithm knows it's a variable spacing, and it creates envelopes to find the worst case effect. Okay? And it picks that loading. And we will use this design tandem also for the load setup. So I will directly create H2LRFD case. I tried to, but maybe, okay. I directly create the H2LRFD case now. So you can close the database. It's connected to our model. We can use it in result case generation. Now we are at the second step, post-analysis procedure step. We will set influence-based result case now. So to do that, let's go results. And influence line surface case.
Click results menu, main menu, and influence line surface case.
Okay.
There are two results on
So you should see a window like this, and you can rename it as LL, and here you will be asked to choose an influence coefficient group. Okay, so you may have multiple influence coefficients generated with the moving load analysis. This might be the case. Maybe you want to consider other effects, centrifugal effects, braking effects. We just created influence coefficients in vertical direction, and we have only one influence coefficient group. So that's why we don't need to select anything here. It's already selected since we have only one influence coefficients group. And now we can enter design lane. Based on HLRFD, the design lane width is 12 feet. And this design lane will be placed on the surface, okay? And the location of the design lane in transverse direction will be decided automatically by the algorithm. And you see this load for extreme force effect option. It should be included for HLRFD. So in HLRFD, we have a requirement for skipping some of the axles if it's not contribute to extreme force effect. Okay, to consider this, we can click this option. And now we can enter multiple presence factors.
What is that overall factor?
Overall factor is, it will just apply a factor to the result, just end result.
Is that like the,
not for enveloping or anything.
Is that like the durability or critical factor?
Durability for critical.
The importance factor.
Importance factor?
Yeah,
it could be.
Okay.
Yeah, we used to use that to apply centrifugal factor. Yeah, we used to use that for applying centrifugal factor, but it could be anything. Congestion factor in IRC we have something like that. I don't know, in AASHTO we have that.
No, the AASHTO one is like, it's like a 1.05. It's more critical.
Yeah, you can use it.
There's like 3 different things they put together, and then you figure out what the multiplier is.
Yeah, you can apply that factor here.
But this is not where you put the normal live load.
No, it's not. It will not apply to the enveloping or anything. It just find the end result and it just multiply with that factor.
How this factor to apply to the result? That's question.
It just
because
multiply.
Because actually you have signed the structure as like an important factor. You have the way to increase your live load or your design load. I mean, here you put here overall factor. What that mean? That mean you have that factor automatically applied to somewhere or other.
Yeah, the surface
how they are? Yeah,
the surface will be higher. Is that what?
Not surface, but it's not applying a load factor. You apply load factor in load case. We just select one for that.
Any case lower than 1, what's the reason if we, I mean, the question as a designer, how do we define this factor? How do we know it's
load factor?
No, the overall factor.
Overall factor is based on your design requirements. It's just an option in the result case.
We'll look at LEAP has the same thing.
With the
LEAP has the same thing. So let's just keep going.
Okay. Tonight?
Did they hear you, the virtual attendees?
I think they hear me. So the question was about the overall factor. So this is the question was about overall factor. The overall factor is the factor which applies to the end results. So the vehicle placement is done by the algorithm. So in the later we will specify some other factors like impact factor, or here we have multiple presence factor, etc. And influence algorithm will find a critical loading, and if you want to increase this loading for some reason for your design, you just use this overall factor. It will apply to the end result. Okay, so let's continue with the multiple presence factors. So this is also a requirement by HTO. Okay, if multiple lanes are loaded, end results, vehicle loading, wheel magnitude should be decreased. So we will use this spreadsheet for that. So we will directly enter the given table by the H2LRFD here. Wheel magnitude should be adjusted based on the number of lanes loaded for the critical case. So this is why we use this multiple presence factor, and this is all automatic, so you don't need to apply this multiple presence factor manually after the I think did I make a mistake here. So you don't need to apply this multiple presence factor after getting the results like you need to do in influence line analysis, because in influence surface we consider multiple lanes loaded case on one result case. Okay, we don't create possibilities manually, so we don't enter these factors manually. We just enter here, and influence algorithm automatically process these factors. And after filling this spreadsheet, you can click OK. And now we can switch to vehicular loading part. So.
Well, they have about 15 minutes, just a time.
All right.
Quick question. Those vehicles, say 2 lanes, do you have a control on what the distance between the vehicles are?
Yes. The question is, can we control the distance between vehicles? Yes, we can. That's why we have this result case. We specify all this spacing condition and everything given by HTO in this result cases. So now we will create vehicular loading. For the vehicular loading, we will specify possibility for the loading. For H2LRFD, we have 3 possibilities. 1, the loading can be just a single design track. 2, the loading can be just a single design tandem. And 3, for 2 design tracks for negative effect, which should place at different spans. So we will define 3 possibilities as lane type here. So I will click on this add lane type button, and for the first case, I select this 2D design track. Please make sure it's 2D, because in this database we also have 1D vehicles. Select 2D design track. And for this loading possibility, we should apply an impact factor because it's a requirement by HTO. It could be applied as vehicle factor here, just under the vehicle load pattern part. It's 133. And well, you can see this vehicle direction. This was a question before, the vehicle direction. It could be any direction. This way our algorithm picks the direction for the vehicle to find the worst case, to find the critical case. And then we can create the other possibility. To do that, I will add another lane type. And I will select design tandem. Again, it should be 2D design tandem. And its factor should be 133. And okay, 133. Just a second. And direction is any. And then we can define our third lane type with design track. You can add vehicle by clicking on this add vehicle button. So we have two design track here. It means that since they are in the same lane type, it means that these two design track will be placed at a single lane, longitudinally. And we have a very important option here. H2 says that place these loading to the separate spans, not the same span. So you need to activate this one load pattern per span option. And this option only works if you have span marks in your roadway definition that we just see. And also for two trucks case, H2 requires to decrease the vehicle loading to 90%. Again, it can be applied as vehicle factor here. So we multiply the impact factor to this 90% to this requirement, and we will apply the multiplication here. And you should apply same factor for the same factor to the second vehicle. Now let's talk about lane loading. Sorry?
Lane load.
Now let's continue with the lane loading. Yeah. Now we will do it. So now we will talk about the lane loading. We set the vehicle part. Now we will set the lane loading. To define lane loading, we need to switch to uniform patch loading tab. So it's exactly should be entered as given in H2. So it says that the load magnitude is 0.64 kip per feet, and the width for the UDL should be 10. And let's switch back to vehicular loading now. We specify the lane loading, the magnitude and the width. So now let's look at our lane types. The first lane type should, sorry, do you have any question?
I lost my load bin.
Okay. Which one?
I hit OK and it went away.
It should not be run away. So you can find it in Explorer, in Analysis Result Explorer.
Analysis.
So it's still there.
Yeah. Here. You didn't lose.
Okay. So, okay. Let me continue. We have very last. Okay, we have 5 minutes then. So let's look at this lane type again. For one lane loaded with design track, yeah, not one lane, with the design track case, UDL can be, the UDL factor can be 1. But for the two vehicle case, also UDL should be decreased to 90%. And we use this UDL factor for that. So you can enter 0.9 for the UDL factor of the third lane type. Okay. Now let's see this minimum back to front spacing. So this will directly apply to this two vehicle case. So the spacing between two vehicles, and it's 50 feet. And this is your question, design lane vehicle margin. It's the spacing between vehicles. Yeah, the idea is that we put design lane within the surface and we put vehicle within the design lane. And this margin will apply to the design lane. I mean, yeah, okay. So it should be 2 based on H2.
To the curve, right?
between
No,
lane
no.
lines. So
It's from the edge of the lane to the.
Edge of the lane, yeah, edge of the lane and the vehicle edge. It applies both sides.
That will be the wheel. The travel would be 2 feet from the curb line.
2 feet from the design lane. To the
curve.
If yes, of course. If your center line is curved, follow a curved geometry, then yes, the spacing will follow.
I think they just mentioned that curve.
We talked about it.
Yeah.
Edge line, yeah.
But
Okay.
it's an edge line because it's more than 2 lanes.
Okay. So I think that's it. Let me check.
Now can we hit okay?
No, we should see graphical results.
No matter what you do, go ahead, okay.
Plus design partner or design standard. How could we add them together? How could we add the HL93 got 2 parts. They know the plus design partner or design standard. We added all these options.
This is design truck. This is design tandem. And
she's
two.
trying to say there are 2 cases, lane load plus track and lane load plus tandem.
Yeah, these, okay, we specify UDL load here, UDL factor. When you specify UDL, it will directly apply to loading lane. So if you skip it, you cannot skip it actually. If you want to skip the lane loading, you just enter 0 factor. If it's 1, it's always included.
This is automatic. The question is that whether we are doing patch loading or not, or lane loading.
Yes, we are doing it. When you can control it with this factor, but you see this factor, UDL factor, it always applies to this lane type. UDL, patch loading, is always applied to the created lane type. You cannot skip it. If you want to skip it, you just enter 0 factor for the UDL. It's always there when you define this magnitude.
They don't want to skip it, but they are just asking about the standard application.
It's always there.
Our standard application is patch loading. The loading that you mentioned, we are just loading, we are just placing the lane load into the critical span. When you're experiencing maximum positive, we are just loading, for example, the mid span, not the support. Yeah, we don't have an option for that. This is all automatic.
Internal, look at, you just specify load magnitude and algorithm automatically finds the patch loading location also, automatically.
Yeah. Also the double track, it will find, and she will show you in a minute.
So you can click OK, and let's see graphical results and spreadsheet results and finalize this day.
One question, if we wanted to add a condition factor.
Condition factor? What?
Reduction factor to live load.
Okay, so let's see the graphical results now. To do that, first I unselect all, go to simple rendering. If you want, you can follow me. If you don't want, you just watch. I will unselect all. I will activate this live load case that we just generated. When you create the result case, it will appear under this influence base heading. So this is the case we just generated, all the conditions. And I will switch to deformed model and activate this displace influence line and surface option. And then I select all. And now I will switch to reaction FC, maximum reaction FC. And now I will click on a joint. This joint, for example, maybe this one. So what I did here is I tell the algorithm that maximize vertical reaction on joint 590, this joint. And to maximize vertical reaction, it finds a critical vehicle loading, 2 lanes loaded case. I didn't draw these lanes manually. I just entered the conditions and it finds critical locations. And these little arrows, these are vehicles graphically, and the little arrows are UDL, the patch loading.
And see, the trucks are going different ways.
Yeah, and yeah, it because we
Yeah. That shouldn't be.
but this is a requirement işte.
No, not within the same lane, but we will fix that now, okay? We will fix
It's
it
all
within
okay.
the same lane.
Okay.
Within the same lane.
Okay.
This is not
Okay.
a requirement actually.
This is why I check output.
Yeah. You are totally right.
Okay. So
You can just select forward or
Yeah, backward.
let's just pick forward.
What?
In the settings, just pick forward.
It doesn't mind that,
In your
generate
settings.
One direction, right? We are doing.
okay, let's do it.
Yeah, you can just change the direction.
Here we can say forward. Let's say forward.
Yeah, forward.
Oh, yeah.
Okay, so it will apply also. I think it's okay now.
Yep.
Yeah.
Okay. And for the lane loading, madam, this was your question. We are just placing the lane loading to the third span. Here. Yeah. This is the patch loading.
Also we have here, these all are patch loading. The little arrows. Okay. So of course for each result, the critical loading is different.
Go back to that view you were showing us kind of from the side there a second. You see how it appears that it's not covering the deck?
Appears not covering the deck.
It appears like the edge of the deck is not getting loaded, but that's not true.
No,
That's a projection of the way the
Oh,
surface
no.
rises up over the deck.
Yeah,
From this
yeah.
angle,
You could
Yeah.
change
it
the
looks
view
like
again and
that's
show
not
that
in the
better.
model, but it actually is all there.
This is
Right.
it's actually loaded, but it shows the
This
influence
display factor.
surfaces.
Yeah, this surface
You
is
could
three-dimensional. It's
Right.
not two-dimensional.
Just trying to
Yeah.
tell people, don't think
This
that
is-
doesn't mean something.
Yeah. We loaded this part, but this is above the surface because these are positive numbers. This is positive reaction when your truck is on the pier.
It's influence surface generated with the
Why is the
movement
outer-
load analysis.
outer span loaded for maximum reaction of the pier? I mean,
Why
the
so?
extreme, the lower.
Do you have one load pattern per span option?
Yes, I
No,
have.
You should pick the pier, one pier, so.
You pick the bottom of the column.
Yeah, the bottom
Yeah.
of the column.
So
And the-
everything as far over
Yeah.
that side as possible.
Yeah, I'm saying.
I selected
first
this
span is loaded.
Maybe you can say minimum reaction.
Not first span.
It's not loaded?
This one? You talked about this one?
Ah, okay.
Oh, these are
It's
zero?
not loaded.
Yeah, that's-
These are not loaded. Loading is showing with purple arrow
Okay.
for the positive case. So, okay. This is how you visualize the graphical results. You can, of course, see the minimum or for other force effect, other reactions for other elements, all critical pattern for each element, each force effect will be different. And also, we can see spreadsheet results. And when you go to spreadsheet results, it will ask an envelope. Okay, we can, again, for reactions, we can maximize force here, vertical reactions. And in spreadsheet, you can see the results are alternates between minimum, maximum, maximum for each joint with support. And you can filter them. Also, I want to mention one thing here. So we visually see the graphics, vehicle locations, and also we report the vehicle locations here in detail in the result case column. So look at this naming convention. So S means the station of the front of the vehicle, as I remember. And T is the transverse offset from the center line of the roadway. And D is the direction of the vehicle. So it's one, I think one is forward. Yeah, we defined forward, so everything is in forward.
The DF is the distribution factor.
Sorry?
What is that 0.377 is the distribution factor?
0.3, which one? This 1.2 or 0.5 is multiple presence factor.
The other one in the second, yeah, that 0.377.
It's transverse offset. T, S means station.
Oh.
We have two vehicles here. We have two vehicles, and their station is 28 feet, and T is minus 0.377 from the center line of the roadway. Okay. So this is how you visualize the, how you see the spreadsheet results. And if you want to see concomitant forces, so under a specific loading, while maximizing the forces at a specific locations, you get the critical loading. And under that one critical loading, you can create a result case for this row, for example, for this joint. It will be the critical for this joint, and for the other elements, for the other joints, you can see the results, and these will be the concomitant results. So I think that's it for today. I will leave the advanced options for refined rating for tomorrow, maybe mention in 2 minutes, if it's okay for everyone. Okay, so recently we implemented new options in our influence-based result cases. So in your current version, you don't have it, but in page 92, you can see another UI, user interface, for this result case. So in this user interface, in the new version, you see mode at the upper left, and this mode can be changed to H2LRFD, and you can see what we have here today. And this mode can be changed to advanced, and in that case you will have some extra inputs, like minimum number of lane input. So with this input, you can say that for a lane, let's assign minimum 1 for this lane. And in that case, this lane will be kept on the surface always, even if it's not contribute to the extreme case. This could be a rating condition for advanced rating. So you will have this option, and you will have another advanced option. It's used for lane placement but omitting results. So for some refined rating conditions, our users wanted to separate the effect of legal vehicle from the effect of the permit vehicle, and they come up with a unique rating factor calculation. So for this, to handle this, we implemented this option. So the lane can be included in lane placements to find the critical condition, but it can be omitted in the results, and you just see the effect of the other lane in the results. So these are implemented for Connecticut DOT for Gold Star Memorial Bridge.
Correct.
Yeah. And this was my final topic today. So thank you for joining.
So just,
was
you know,
a long
before
day.
we give a hard end to that, are there any questions at the table or in our virtual group related to influence surface slide look?
Quickly, you are referring the placement of the vehicle with respect to the lane, right?
Sorry, can you
To the design lane.
Design lane.
Yes.
So it will